Okay, so today we're going, it's the same section, it's still trigonometry, and actually what we're doing today, super similar to what we did yesterday, just kind of looking at different operations. So yesterday, if we had an angle and a side, we were able to find another missing side. What we're going to be doing today is we're going to be looking for an angle. Now the good thing is you use the exact same ratios, you use them almost in the same way, but how you solve your problem is what's going to be a little different. So we're going to be using inverses today. So the inverses that we've known up until now, the inverse or opposite of addition is subtraction, the inverse or opposite of division is multiplication. And then we kind of even could add the inverse of squaring a number would be a square root of a number. So in math, a lot of things work off of inverses and opposites. And it turns out that there's inverses of these sine, cosine, and tangent functions. So when you see this sine to the -1 power, that's the inverse of sine, the inverse of cosine, the inverse of tangent. And you can use that to help you find the measure of an angle. So let's look at this one, and you'll kind of get an idea of what we are doing today. So notice in this problem, if we want to find the measure of angle x to the nearest degree, a lot of what we do today is going to be the same thing we did yesterday. You're going to look at the angle. Notice yesterday I had the angle. It would have said that's like 20 or 30 something. But I would have only been given one side. Today I don't have the angle, but I do have two sides. So what I can do is I can look at this angle x, the one I'm looking for. And just like yesterday, I'm going to look at the sides that I'm given. This side that's 6 in relation to angle x is what side? Opposite. And the 10 is hypotenuse. And just like yesterday, we have SOHCA, TOA, OH belong with which ratio? Sine. And it's still the same thing. You're going to take sine of an angle equals the opposite over the hypotenuse. The difference today, when I take sine of an angle, I don't know the angle. That's what I'm looking for. So just like every other time in math, when I don't know something, we use the variable. I'm looking for x. I'm looking for, remember, whatever comes after sine, this is an angle measure. I'm taking sine of what angle would be opposite over hypotenuse, 6 over 10. So really, so far, not a whole lot different than yesterday, right? Just kind of changes where your variable is. Now yesterday, we had sometimes where we had to divide by sine of 12 or divide by tangent of whatever. And you might be tempted to do that here, but remember the reason why we did that yesterday, so like this one here, when I was solving for x, it was x times sine of 55. Sine of 55 is a value. If you plug sine of 55 in your calculator, it's going to give you a number, right? Because you know what sine of 55 means is in a right triangle, if you have a 55-degree angle, sine of 55 will tell you the ratio of the opposite over the hypotenuse of that triangle. This is the number. The problem with this today, I can't divide by sine. Because if you try, like in your calculator, if you just plug in sine, not sine of anything, it's not going to let you do that. Okay? You can't just plug in sine, it has to be sine of something. So to get rid of the sine, that's where you're going to use the inverse operation. So to get rid of sine of x, all you do is you take the inverse of sine. Okay, it would look something like this. So when you take the inverse of sine of x, just like when you square a square root, the square and the square root cancel each other out, the sine inverse of sine and the sine they cancel out, all you're left with is x. So the inverse of sine and sine cancel out. But just like everything else we do in math, if you're going to take the inverse of sine on the left, guess you have to do it on the right. Okay, take the inverse of sine on the right. So to solve for x, once again, you're going to have your calculators today. on your calculator, it's probably going to be wherever your sign button is. Above the sign button, you should see the inverse sign button, okay? To get to that inverse sign button, you may have to hit the second key, okay? So hit second, and then the inverse of sign, and then plug in 6 divided by 10. And once again, just like yesterday, I want you guys to practice this. You should get 37 degrees. And once again, I want you to practice so you're able to do it whenever you get to your homework. If you're not getting that, let me know. Okay. Any other questions? That's what we're doing today. Okay. Let's get this glued into page 25. This is still section 8.3. Let's call it 8.3. So I would say, I think to some extent, I think today might be a little bit easier than yesterday, and hopefully you did okay with yesterday, because it's really not a whole lot of things that are new. The big new stuff in this section was kind of getting to use those ratios and understanding them, and that part's the same today. Now where your variable is going to be, that's where it's different today. So number one, we're looking for the value of x, which is going to be an angle. So in this first triangle, that top angle is going to be x. My right angle is going to be m, and the other angle will be n. Okay, this left-hand side is going to measure 15. Xn will measure 20. Now, like I was saying, a lot of what we do today, it's the same as yesterday. I'm looking for the measure of angle x, so we're going to find our angle, and then we're going to look at the sides that we're given in relation to that angle so we can decide which ratio to use. So that 15, what side is that in relation to the x? It is the adjacent angle, or sorry, the adjacent side. And then the 20 is the hypotenuse. So remember, SOHCAHTOA. Which ratio are we going to use? Cosine, right? CAH. So remember, when you take sine, cosine, or tangent, you are taking sine of an angle, cosine of an angle, tangent of an angle. If you don't know the angle, we're going to take cosine of x. That's what I'm looking for. I want to know what angle would this be. Now I know the ratio. The ratio is going to be adjacent, which is 15, over hypotenuse, which is 20. Now this, really for the most part, is the same as yesterday. Your variable is just in a different place. Now what you have to decide, and what's going to be tricky, I guess, more as we get into tomorrow, because tomorrow we're going to throw in what we did yesterday and what we did today. You have to decide which of these inverses, which operation you're going to use to solve for x. Remember, you can't divide by cosine, because cosine by itself doesn't mean anything. You have to have cosine of an angle, so you can't divide by cosine. So to get rid of the cosine, this is where you take the inverse of cosine. So in your calculator, what you're doing is you're going to take the inverse of cosine. So you're going to do the second cosine button, and then you'll plug in 15 over 20. And once again, I want you guys to practice to make sure you can get the right answer. You should get 41. And just like yesterday, if you are not able to get that with your calculator, you need to let me know. Now, if you don't have a calculator with you right now, when you guys get to your homework, because you should have quite a bit of time doing your homework, you can do almost the entire homework assignment up to this point and know exactly what you're going to need to plug into your calculator. And then when you get home or get access to a calculator borrowed from a friend, I know you can get on the internet, you can get on any computer, any calculator you're going to use, unless it's like a super, super basic 4-function calculator, will have the trigonometry ratios on it. Okay, so you can use that. Okay, anybody not able to get 41? Okay, number 2. All right, so let's draw our right triangle. This bottom angle is going to be x. My right angle is going to be y. The other angle will be z. the top is going to be 100, and that right-hand side is going to be 41. Now we're wanting to find the measure of angle X. We're wanting to find that angle right there. So we're going to look at the sides that we're given. So this 41, what side is that in relation to X? That's the adjacent side. And the 100 is the opposite. So I have O and A. So TOA. Which ratio is this? Tangent. Remember, you're taking tangent of an angle. If you don't have the angle, that's where your variable is. I'm going to take tangent of X. When I take tangent of X, when you take the tangent of any triangle that has that angle measure, you know the ratio is going to be opposite, 100, over adjacent, which is 41. And then once again, to get rid of the tangent, since it's just tangent, you are going to take the inverse of tangent on both sides. So on your calculator, you'll do second tangent, which will give you the tangent inverse. Once again, practice that. We should be 68. And for the angles, we'll round to the nearest degree. I think in some ways it's easier than we did yesterday, because it's kind of just one step in the answer. Okay, let's try a couple more. Okay, number 3, another right angle. Right triangle. Okay, this angle over here on the right side is going to be X. Yes.
What did we get?
Should be 68. The right angle is going to be W. That top angle is going to be U. Okay, this side is 7. The hypotenuse is going to be 13. Okay, once again, we're looking for angle X. So I want you to think about it. Think about what two sides you have. What two sides do I have? What's the 13? Hypotenuse. And what's the 7? Opposite. So which? That's not right. I was like, what the heck? Okay, it's going to be sine, right? Sine is opposite over hypotenuse. So we're going to take sine of X, and then we're going to take opposite over hypotenuse, so 7 over 13. And then same idea, we're going to take the inverse of sine on both sides. So when you take the inverse of sine of 7 over 13, we should get 33. Very good. Okay, why don't you guys try the last one of these on your own? So we've got a couple more to do. All right, so number 4. Okay, this angle over here on that side is X. P is going to be the right angle, and Q will be the other one. This top side is 8, and that long one is going to be 10. So I want you guys to try that one on your own. Like I said, even if you don't have a calculator, you can go ahead and get all the way to the point where you need to plug it in your calculator. You'll just have some finishing to do, and you get access to it. Okay, if I'm solving for X, what ratio am I going to use? Cosine, yeah, because I have adjacent and hypotenuse, so we would take the cosine of X equals, adjacent is 8, hypotenuse is 10, so we would take the inverse of cosine of 8 over 10, and we should get 7, very good. Okay, the last thing we're going to do is do a little bit of combining what we did yesterday with what we did today. So we're going to find the values of W and X. If it's a side length, we'll round to the nearest tenth. If it's an angle, we'll round to the nearest degree. So number 5, let's draw a big right triangle. And then we're actually going to draw a smaller right triangle inside this triangle. So that top, just bring it down to that side right there. So my W is going to be that segment right there, and the X will be the other segment right there. Okay, this angle in here is 45, and this angle here is 35. And then this left-hand side over here is going to be 5.5. Now, I'll be honest with you, whenever I did this one the first time, I worked way too hard. So if I want to find W, what I did is I'm like, okay, well, I have the 45-degree angle. I have opposite and adjacent. So let's do tangent of 45 equals opposite over adjacent. And I went through all of that. And then whenever I got my answer, I was like, I didn't need to do that. Do you know why? You could do that. Oh, yeah, you could do the big length and then subtract it. But you could actually figure out what W is without doing any work at all. Look at this little triangle. Isn't it a 45-degree triangle? Which is awesome. Because what do we know about the legs of a 45-degree triangle? Yeah, they're congruent. So we already know that W is 5.5. You don't have to do any work. Now, if you went through the process of taking tangent of 45 equals 5.5 over W and solve that, you would get the same thing. Okay? Now, here's the part that can get a little bit tricky. When I want to find X, you have to keep in mind that these ratios only work for right triangles. So I can't, look at this triangle here because it's not a right triangle. Okay? What I'm going to have to do is I'm going to have to look at the big triangle. Because if you look at this big triangle, I have an angle, I have a side. So if I use the angle in that side, I could find this entire side. And I already know what that is. Right? So if we find the entire side, we can take away that 5.5 to find the X. Okay? So if we're looking in relation to the 35, what is the 5.5? It's opposite, and then the whole side down here is adjacent. So opposite and adjacent is which ratio? Tangent. Now, remember, we're taking tangent of an angle. So far today, I didn't know what the angle was, but I know the angle, right? I know what tangent of 35 is. Well, I don't know what it is, but I can figure it out. You can plug that in your calculator. Tangent of 35 is a number. It's a value. It's a ratio. Okay? Now to find tangent of 35, we're going to take opposite, which is 5.5, over adjacent. I might just leave it as A because we don't really have a variable defined for us for the entire thing. Okay? Remember from yesterday, this is one that takes a little bit more work because the variable's in the denominator. So to get the variable out of the denominator, multiply both sides by A. So we would have A times the tangent of 35. And on the right-hand side, we just get 5.5. Now here's where it can get a little confusing. Because today I introduced you to the idea of the inverse operations. I don't have to do that here. Because remember, tangent of 35, you could plug that in your calculator. It's a number, right? And if it's a number, this is A times that number. So get rid of that number. We can just divide by tangent of 35. So this is what we did yesterday. Okay? And whenever you do that, okay, we should get, and if I maybe keep a decimal just for safekeeping, we get about 7.9. Be careful, that's not my answer. Remember, because that 7.9 is that whole side. I just want that little piece right here. So if the whole thing is 7.9, this right here is 5.5. 7.9 minus 5.5. You should get x would be 2.4. Okay, questions on that one? Now let's do one more kind of like that. Okay, so let's do a big, long triangle. Actually, kind of two triangles in here, two little right triangles. Okay, that segment going up is going to be our W. This angle over here on the right is going to be our X. This angle on the left is going to be 32. The left side is going to be 5, and the right side is going to be 6. So I'm looking for two things. I'm looking for W and X. I'm going to have to find W first because I kind of have two triangles here, right? I have this triangle. Remember, to use these ratios, what we did yesterday, we had an angle and a side length. Today, we had two side lengths, and we were looking for the angle. So you either have to have an angle and a side length, or two side lengths. Notice in this right-hand triangle, I just know one side length, so I'm going to have to start over here. So if I look at this 32, in relation to the 32, we have that side and this side. So the W is what? Opposite the 5? Yeah, hypotenuse. So which ratio? Sine. So remember, we're taking sine of an angle. I know the angle. It's 32. We're going to take sine of 32 equals opposite, which I don't know, over hypotenuse, which is 5. Remember from yesterday, to solve for W, to get rid of a divide by 5, we're going to multiply by 5. So we end up with 5 times sine of 32, which is what you would plug in your calculator. And we should end up with, if we round to the nearest tenth, you should get about 2.6, which we're going to need to help me solve for x. So here, whenever I move to solve for x, what sides do I have in relation to x? Opposite and hypotenuse again. So we're going to do sine again. Now this time, I don't know the angle. So we're going to take sine of x equals opposite, which we just found is 2.6, over hypotenuse, which is 6. Now for this one, remember, if I want to solve for x, if you're thinking, well, I'm just going to divide by sine, you can't divide by sine. Sine by itself doesn't mean anything. You have to take sine of something. So to get rid of this sine, this is where you're going to take the inverse of sine. And when you take the inverse of sine of 2.6 over 6, you should get about 26 degrees.